All right, so this is lesson 2-3, and I am Mr. Ryan. And this is the summer edition of 9th grade math. And what we're going to do today is, I'm going to move this, we are going to answer two kinds of questions. We're continuing with understanding coordinate planes and shapes on coordinate planes using lines, okay? And what we're going to do here is we learned in the last couple lessons that we can draw a rectangle on a coordinate plane. Now, it doesn't have to be a rectangle. It could be, you could also put a triangle. You could also do a trapezoid and all kinds of other shapes, okay? But we're sticking with rectangles for these examples, okay? And what we want to identify here is we want to answer the question, what is the perimeter of this rectangle, this quadrilateral ABCD? We have A, B, C, D. And then we want to answer the question, what is the area of rectangle ABCD, okay? So just a quick reminder before we start into this, how do we identify the perimeter of a geometric shape? Well, very simply, we find the length of all the sides, and then we add up the lengths of all the sides. So one of the sides is AB, another side is BC, another side is CD, and then another side is AD. And so basically, what we got to do here is the perimeter. What we're basically doing here is we're just adding up four numbers. So the perimeter of a quadrilateral, in this case, is going to be whatever the length of AB is, plus whatever the length of BC is, plus whatever the length of CD is, and then plus the length of AD, okay? And in lesson 2.2, we learned how to identify the lengths of these sides. If you recall, we used the distance formula. So for example, the distance of AB is going to use the formula, and the distance of all of them is going to use the same formula. You have to identify the coordinates of A and the coordinates of B, and the distance is the square root of x2, one of the x coordinates, minus the other x coordinate, x1, and then we square that, plus y2, one of the y coordinates, okay, 2 minus y1, and then we square that. And so this is our formula. So if we use this formula, we'll find the length of this line segment AB. If we do the same thing for BC, and then the same thing for CD, and the same thing for AD, we will have four lengths. And if we just add the four lengths together, that'll give us the perimeter, okay? And so that's what we're going to do here, all right? On the other hand, let's think about the area. That's the other thing we're going to do. And I want to remind you that the area of a rectangle is just simply equal to the base of the rectangle times the height of the rectangle, okay? So if we know the height of the rectangle and we know the base, the length of the base and the length of the height, well, this CD, that is the base. This is the base. I mean, we really can say any of the sides is the base, but let's say that CD is the base, and we'll say that, AD is the height, okay? And so all we need to do is find CD, okay? So what we'll have here is CD will be equal to the base, or sorry, the area of the rectangle will be line segment CD times line segment AD. That's it. Just two of the dimensions, multiply them together, and that gives you the area of the rectangle. So that's all we're going to do today. Okay? So let's go ahead and do this one that's in front of us right now. Go ahead and do some erasing here. Okay. Right. And we will. So what are we going to do? Well, the first thing we want to do, like we've done in the other examples, is the first thing we needed to do was identify the coordinates of the points. So we need the coordinates of A. Okay. A is at the point 3 and 9. Okay. So 3, 9. Okay. And then B is at the point, let's see, what we got here. Is that 15 and 12. okay? 15, comma 12, okay? Now, this will only give us the length of AB. We then have to go back and do, BC. In fact, let's go ahead and identify BC. Let's identify the point C, okay? C is going to be at, let's see here, this is 16 and 8. 16, 8. All right, very good. And now we can use B and C to find the length of BC and AB to identify AB. Now, here's what I will remind you, is that AB is the same length as CD, and BC is the same length as AD. And therefore, all we have to do is find two lengths, and then we can identify the other two that are the same, and then just add up the four numbers, okay? All right, so let's start with what is the distance. Identify the distance of AB, okay? All right, well, we'll call this one x1, and we'll call this one y1. So 3 is x1, and 9 is y1. We'll call 15 x2, and we'll call 12 y2, okay? And so we're going to do the square root of x2, in this case is 15, minus x1, which is 3, squared. We're just using the formula here, okay? Plus y2, which is 12, minus y1, which is 9, okay? And we're going to square that, okay? And so that's going to be equal to the square root of 15 minus 3, that's 12. 12 squared is 144. I mean, you can do that in a calculator if you need to, but that's the right answer. 12 minus 9 is 3. 3 squared is 9. So we're going to do 144 plus 9. And so our answer here for the distance is the square root of 144 plus 9 is 153. So the length of this, A to B, is the square root of 153. Now we know that CD is the same length. So down here we're going to say that CD is the square root of 153 as well, okay? Now let's find BC, okay? So for BC, we're going to call 16x1, and we're going to get rid of this. We're done with A, okay? We just need B and C. We're going to call 16x1, we're going to call 8y1. And B, 15 is x2, and 12 is y2, and that's fine. Okay, we can pick either one to be the ones and either one to be the twos. The distance of BC is going to be equal to the square root of, that's a little messy, but we'll do the best we can with it. So we're going to do x2, which is 15, minus x1, which is 16, okay, squared, plus y2, which is 12, minus y1, which is 8, okay, squared, okay, and that's going to be equal to the square root of, okay, well, 15 minus 16, that's negative 1. Negative 1 squared, that means negative 1 times negative 1. Well, negative 1 times negative 1 is just 1, okay, plus 12 minus 8 is 4. 4 squared is 16, so this is going to be 16. And so that is 1 plus 16, that's 17. So we have the square root of 17, okay? And so BC is equal to the square root of 17. We also know that AD is the same length, so that's going to be the square root of 17. Okay, there we go. So we have our four lengths, and so now, here, I want to erase this because I'm running out of room. This area, okay? So now, to identify the perimeter of rectangle A, B, C, D is going to be equal to, okay, it's going to be equal to, I'm just going to add up the four sides. I'm going to do the square root of 153 plus, and we have the square root of 17, that's the next side, plus the square root of 153 plus the square root of 17. Okay, now we can't combine these. We can't add them up. The only thing we can really do is we could say that there are 2 square root of 17s and 2 square root of 153s. It doesn't really help us much by simplifying like that. But what you may not do, you may not simply add up the 153, the 17, the 153, and the 17, and then just put a radical over it. You cannot do that. Okay, what we say is that addition does not, radicals do not distribute over addition. It doesn't work that way. They have to remain separate. If we want to get a final answer, so this is your answer, unless you use a calculator, which we're gonna. So we're now going to go to the NumWorks calculator. Here we are. We want to use the calculator, so we've got to arrow over to the calculation, press OK, and now let's see if we can remember our numbers, 153 and 17. Okay, so we're going to key in the square root of 153. Now, I have to arrow out of the radical. I have to move out of the radical, so I have to hit the side arrow button. Otherwise, I'll stay under the radical, and I don't want to do that. Plus the square root of 17, then I have to arrow right to get out from under the radical. There we go. Plus, again, the square root of 153, then I'm going to arrow out. Then we're going to do plus the square root of 17, okay? And then we're just going to press enter. And here's what we're going to get. It actually winds up being 8 square root of 17, okay? And so we can write that. You can use the NumWorks calculator to simplify your radical. And then we can also say that it is, I'm going to move my head out of the way here. We can also say that it's 32.9848. 9848. 32.9848. Okay, so what we say it was 8 times the square root of 17, which is 38. We say 9848. Let's check it out again. 9848. Okay, 38.9848, and that's the answer that you will plug in if it's the exam. On the worksheet, this can be your answer. This can be your final answer. Use the calculator. Okay. So the perimeter of this rectangle is 38.9848. Okay. All right. So now we want to do the area. To identify the area of triangle, I'm going to move my head back down here so you can see it. Okay. The area of rectangle ABCD is equal to the base times height. Okay. Well, the base of this rectangle is the square root of 153. We said it was CD. So you have to do CD times AD. It's these two dimensions. So it's going to be 153 times, or the square root of 153 times the square root of 17. Okay. So we have the square root of 153 times, now I don't know if you've ever seen this dot used as multiplication, but a lot of times we use we call it a middle dot, just a dot, and it represents multiplication, times the square root of 17. Okay. And that is equal to, now, with multiplication, you can actually make it a single radical. So with multiplication, you can actually distribute a radical over multiplication. So we can just do the square root of 153 times the square root of 17. Or sorry, we can just do 153 times 17. I'm going to prove it to you. Okay. If I just do 153 times 17, I get, here we go. Let's move this up here. 2601. Okay. So what I'm telling you is that this area is actually equal to the square root of 2601. Okay. Now that happens. Well, we'll get to the square root in a minute. Okay. But the question is it true then that the square root of 17 times the square root of 153 is the square root of 2601? Well, the answer is yes. If I do it, though, they're likely to do a simplification. But let's try it. Square root of 153, and we'll arrow out, and then times the square root of 17. Enter. It's actually equal to 51. Wow, that's cool. So the square root of 2601 is actually 51. And that's convenient. But let's make sure square root 2601, execute, yep, it's 51. And so what I said is true, that this times this is equal to the square root of 2601, which is equal to 51. And so what we're going to say is that the area of this rectangle right here is 51. Okay. All right, so that's how to identify the perimeter of a rectangle and how to identify the area of a rectangle on the coordinate plane. Okay, I think we should do a couple more examples. Okay, let's identify the perimeter and the area of this rectangle over here, EFGH. Okay, and so what we're going to need is we're going to need the length of EF, we're going to need the length of FG, we're going to need the length of GH, and we're going to need the length of EH. Okay. Now, since it's a rectangle, we only have to find two of them. So we have to find EF and FG. Okay. And so let's find the coordinates first. It's always the first thing we're going to do is the coordinates. E is the point 5, 11. Okay, good. So 5, 11. All right. F, we're going to call it 5x1 and 11y1. Okay. F is at the point 14 and 8. Right here, good. 14, 8. Okay, and that's going to be x2 and y2. And then G is at the point 12 and 2. 12, 2. Okay, we'll come back to labeling G after we're done with E and H. All right, so the distance of EF is going to be equal to the square root, okay, of x2, 14, minus x1, 5, squared, plus y2, 8, minus y1, 11, squared. And so that's going to be equal to the square root of 14 minus 5. That's 9. 9 squared is 81. So 81 plus 8 minus 11, that's negative 3. Negative 3 squared is 9. And so 81 plus 9 is the square root of 90. I think we've done this one before, maybe. Okay, 90. Okay, great. Now we need the distance of FG. Okay, to find that, let's see, we don't need E, so we'll get rid of these. We'll call 12x1 and we'll call 2y1. Okay, so the distance of FG is going to be x2, 14, minus x1, which is 12, squared, plus y2, which is 8, minus y1, which is 2, squared, and that equals, okay, so we'll do the square root of 14 minus 12, that's 2. 2 squared is 4. 4 plus 8 minus 2, that's 6. 6 squared, that's 36. Now, if you need to do some of these on paper or in a calculator, that's fine, okay? So what we have here is 4 plus 36 is 40, so we have the square root of 40, okay? And so that means that this E, this is the square root of 90, and that means that GH is also the square root of 90 because it's a rectangle. Okay. What's happening there? Okay. And then we've got the square root of 40 over here, and that means this one over here is also the square root of 40. And so now if we want the perimeter, we just need to add up. We just need to add up the square root of 90 plus the square root of 40 plus the square root of 90 plus the square root of 40. And then we'll look at that in a calculator, okay? So perimeter is going to be equal to the square root of 90 plus the square root of 40 plus the square root of 90 plus the square root of 40. Okay. Now, we could simplify these. We're not going to right now. We're going to do that in another lesson in week 3. But for now, we can just key these into a calculator. So we'll do the square root of 90, okay, arrow over, plus the square root of 40, arrow over, plus the square root, there it is, of 90, arrow over, plus the square root of 40, and then press enter, and we wind up with 10 square root of 10, which is 31.622. Now, see this 6227? But this next number is 7, and that means this 7 is going to round this 7 up to an 8. So we're actually going to put 31.6228. Okay? All right, 31.6228. So we're going to put 31.6228, which, by the way, simplified was 10 square root of 10. Okay? Now to find the area is just base times height. Okay? We can take this, we can call this the base. That's the base, and that's square root of 90 times this is the height, square root of 40. So we're just going to do square root of 90 times square root of 40. Okay? All right. So square root of 90 times square root of 40 equals, now 90 times 40 is equal to 3600. Okay, now if you're not sure, let's go ahead and look at it. Look at the numworks. 90 times 40 is, yep, sure enough, 3600. Okay, and so because that's 3600, that means that this is going to be square root of 90 times the square root of 40 is the square root of 3600. Now we can do the square root of 3600 in the calculator. So square root of 3600 is going to be 60. Okay, so it's actually a perfect square, so it's 60. And so now the area of this triangle is equal to 60, and that's our final answer. Okay, I think we should do just one more example. Okay, so we've got one here. Let's go ahead and give some labels here. Let's call this maybe M, N, O, P. All right, so we've got rectangle M, N, O, P. That's very ugly P, but it'll do. We want to identify the perimeter, and we want to identify the area. Okay, so we need some sides. We need the length of side MN. We need the length of side NO. We need the length of side OP, and we need the length of side MP. Okay, but it's a rectangle, so we only need to get two of the sides. Okay, so we need to identify the length of side MN. Well, point M is at, looks like 5, 13. Okay, so this is going to be 5, 13. We'll call that X1 and Y1. And then N is, looks like it's at the point 15 and 7. So it's going to be 15, 7. We're going to call those X2 and Y2. Let's go ahead and get point O real quick. Point O is at 12 and 2. And we'll eventually call those X1 and X2, or X1 and Y1, I mean. All right, so we need to find the distance of MN, and we're going to use the formula. We get a square root of X2, which is 15, minus X1, which is 5, close parenthesis, then square, plus, parenthesis. We need Y2, which is 7, minus Y1, which is 13, and we're going to square that too. That's going to be equal to the square root of, all right, well, 15 minus 5, that's 10. 10 squared is 100. Okay. Plus, and then we have 7 minus 13 is negative 6. Negative 6 squared, that's negative 6 times negative 6, and that's 36. So it's going to be 136. If we add them together, we get the square root of 136. Okay, so mn is equal to the square root of 136. That means that OP is also the square root of 136. Okay, now we need NO. So we want the distance of NO. Okay, and we don't need M, so we can get rid of X1 and Y1 up here. Okay, and we can call O X1 and Y1. Okay, and so to find the distance of NO, we're going to do the square root of X2, which is 15, minus X1, which is 12, and then close parenthesis and square, plus parenthesis, Y2, which is 7, minus Y1, which is 2, and we're going to square that. And so let's see what that equals to. Square root. Well, 15 minus 12, that's 3. 3 squared, that's 9. 9 plus 7 minus 2, that's 5. 5 squared, that's 25. So 9 plus 25 is 34. So this is going to be the square root of 34. Okay. And so this segment NO is equal to the square root of 34. And that means that MP is also the square root of 34 because it's a rectangle and those are the same length. So now we just need to add up square root of 136, square root of 34, square root of 136, and square root of 34 again. Okay? And so the perimeter is just the sum of the 4 sides. Okay. Square root of 136 plus the square root of 34 plus, again, the square root of 136 plus the square root of 34. And so now we're going to go over to the calculator, the NumWorks calculator, square root of 136, square root of 34. So we're going to square root of 136, come out of the square root and say plus. Whoops, hang on a second. I did parentheses, not square root. There we go. Square root 136, okay, plus square root of 34. And come out of there, plus the square root of 136, plus the square root of 34. And that's going to give us 6 square root of 34, which is 34.9857. 34.9857. So we got, whoops, 34.9857. That is the perimeter of this rectangle. Okay. Now to get the area. So the area is base times height. The base, we can call OP the base, and we can call the height MP. So we just need square root of 136 times the square root of 34. So the area is going to be the square root of 136 times the square root of 34 equals the square root of, well, let's just multiply 136 times 34. 136 times 34, and that's 4,624. Okay, 4,624 equals, and so now let's identify the square root of 4624. Square root 4624. And that's going to be equal to, let me get my head out of the way here, is 68. Okay, so the final answer here is 68. Okay, and so that means that the area of this rectangle is 68 square units, whatever that is. 68 of these little squares, and you can probably, if you turned it, you could probably squeeze in 68 squares in there. Okay, and then the perimeter is 34.9857. Okay, all right, I have several of these, I think 8 of these for you to do, where you identify the perimeter, then you identify the area. Make sure you do them all and check them and make sure you get them right. And that's it for lesson 2-3.